Hello everyone, how are you all? I hope सब अच्छे होंगे. So today we are back again with the mathematics shorts. Now in mathematics shorts we are basically going to talk about tips and tricks to solve the questions. Okay, you know how important is to solve the question very quickly in a competitive exam and how to manage the time. So today we will be basically talking about a very important formula in definite integral, that's the Walli's formula, which actually helps to solve the question when a given particular type of limit is given. So let us start with the mathematics shorts, and there will be many shorts coming up in the continuation of this particular series. Okay, so I am starting with today with the Walli's formula. Okay, so as you can see the Walli's formula over here, the Walli's formula is given over here. Now this particular Walli's formula comes very handy when you actually given particular integral with a limit from 0 to pi by 2. Now I am gonna be making it very clear, only applicable for limit 0 to pi by 2. Now when and whenever only 0 से pi by 2 का लिमिट दिया रखा होगा and you are given with some expression like this, okay, and you are given an expression like this, sin की power nx dx or cos की power nx dx, then you have to apply this particular formula with the which is the formula is given as this particular thing. Though it has two different distinction. जब n का value odd हो तो ये वाला formula लगाना, जब n का value even हो then you have to only multiply with basically this particular factor which is pi by 2, and I'm going to be making it very clear how this derivation comes. Okay, again another important form of Walli's formula. This is the first Walli's formula that you have to keep it very important and remember it in mind, and the second Walli's formula that you have to keep in mind, that sin की power mx and cos की power nx dx, then this particular formula comes, and when m and n both are positive integer, then you have to multiply with a particular constant which is pi by 2. So let us come and check and how the derivation is actually made for this particular question. So if we are dealing with this particular limit is sin की power nx dx, now we actually have studied about reduction formulas. Okay, so we have actually studied about reduction formula. So if I say this particular integral is some which is represented as a of n, and if I say you have to particularly find the indefinite integration of this function sin to the power nx dx, then what you will actually do, you will think of and apply the by parts and get a recurrence relation. So if I talk about by parts, so you know that by part u into v, that is again and some differential, okay, and if you are actually finding you have to find the integration value. So if this particular first function and this is the second function, so you know this u into integration of second function minus differentiation of first function into integration of second function, and then again putting the limit, that is dx, and then for this particular whole thing and this particular whole thing, then again dx. Okay, so if u and e both are function of x, okay, both are functions of x. Okay, now based on this particular thing, if we actually take this indefinite integral, that is sin की power nx dx, and if we are trying to solve without limit, then if we can expand this particular thing as sin x into sin की power n minus 1x dx integration. So why did I write like this? So when I write like this, I can actually integrate this particular function, but I can't integrate this particular function. But if I go on integrating this particular function in form of a differential, and then we actually get the recurrence relation. So that's what we are trying to see. So this particular function, if I label it as the first function and this is the second function, or this is u and this is v, then we can by parts we can apply by parts and we can get to the result as this will be sin की power n minus 1x as it is into cos of x, and a minus sign will be there, minus of integration of first function का differentiation. कैसे होगा first function का differentiation, that is n minus 1 into sin की power n minus 2x into cos of x, and cos of x over here, and then if I integrate the second function again, there will be minus of cos x, and this will make up sin cos square x, and there will be minus, so which comes at plus, and there will be dx over here. Now if I particularly observe this particular situation, then I will get this particular thing somewhat looks like the same integral. So what I can do, and we all know that sin and cos are actually related by very important rule, that is sin square x plus cos square x is actually equal to 1. Okay, so sin square x plus cos square x is equal to 1, and if I take this particular limit integration, that is minus of sin n minus 1x into cos x plus, and if I take this cos square x as 1 minus sin square x, then I am going to get the result as n minus 1 sin की power n minus 2 x minus of n minus 1 okay, and then I'm gonna get a sin k power nx dx, and whole this will be dx. So what I see over here, this particular thing is actually a of n, and this particular thing is given over here is a of n minus 2. So what I can write from here, I can write a recurrence relation such that this is my recurrence relation, and if I take this particular thing this side, then I'm gonna get as n minus 1, and plus of over here there is a of n, and n minus 1 plus 1, that is n times of a of n is equal to minus of sin k power n minus 1 x into cos x plus a of n minus 2 into n minus 1. Now if I write the recurrence relation, recurrence relation will come out something like this. So sin k power n minus 1 x into cos x plus n minus 1 divided by n into a of n minus 2. So this is the recurrent relation we actually study, and if we try to put the limit of the integral, and if actually we put the limit of the integral from 0 to pi by 2, what we are getting the result as? Now this particular result will come as, if I put 0 to pi by 2, if I put pi by 2, cos x will be 0, and if I put 0, then sin x will be 0. So this particular thing on putting the integral limit from 0 to pi by 2, that's why the result is very important and only applicable for 0 to pi by 2. This particular quantity on putting the limit comes to 0. This particular quantity on putting the limit comes to 0. So this will be basically n minus 1 times by n of the particular integral, that is 0 to pi by 2 of sin of n minus 2 x dx. So if we try and solve out this particular recurrence relation and solve out, so we will get some results which is actually known as the Walli's formula, So what we actually see over here, on putting the limit a of n comes out something as n minus 1 times by n into a of n minus 2 into a of n minus 2. And if I go on again, so what we see over here, क्या देख पा रहे हैं ना, जब a of n है ना, तो ऊपर पार्ट वाला में n minus 1 आ रहा है और नीचे में n आ रहा है. So if I again go on and try this particular reconciliation again over here, so what will I get result with n minus 1 divided by n, and over here क्या मिलेगा, एक से काम कर दो इसको, तो n minus 3 divided by n minus 2, and I can write this thing as what you see over here कि जो यहाँ पर है उसका दो डिफरेंस कम होने वाला है, कि a of n का लिख रहा है तो दो डिफरेंस कम है, तो दिस विल बी a of n minus 4. So if I go on and so on, if I go and write this particular relation as a recurrence, so what we are end up getting as a result is some products, okay, some products divided by n into n minus 2 and some product, and up till how much we should proceed. So there is two particular thing ना, जब n का वैल्यू odd होने वाला है ना, तो ऊपर वाला जो पार्ट है, you see n is odd, then n minus 1 is obviously even part, so यहाँ पर जो end होगा वो even से होगा, and you see n is odd, so n minus 2 will be again an odd number, so यहाँ जो end होने वाला है 1 या 3 से end होने वाला है, so actually 1 से end होने वाला है, okay, so I won't write 3 over here, and similarly 1 का जो product है वो basically doesn't makes a very big difference. Okay, so this is 1 over here, and there will be a quantity which is left out, this is a of 1, and if we actually calculate a of 1 का value क्या है, 0 से pi by 2, and if we actually calculate this particular limit and this integral, then we are getting the result as 1. And if n का value अगर even है, then what will it end up getting in the result as n minus 1 and this product n minus 3 and this so on 2. अगर देखो n अगर even है तो ऊपर वाला पार्ट क्या होने वाला है, odd होने वाला है, तो this will end with 1. एंड सिमिलरली अगर n इवन है तो नीचे वाला जो प्रोडक्ट है वो कहाँ से एंड होने वाला है, 2 से, एंड साइमल्टेनियसली क्वांटिटी विच इज एक्चुअली a of 0. सो व्हाट इज द वैल्यू ऑफ a of 0? a of 0 का वैल्यू क्या होगा, 0 से pi by 2 sin की पावर 0x. ना sin की पावर 0x क्या होता है, बेसिकली 1 होता है. एनीथिंग की पावर 0 विच इज अ गुड क्वांटिटी एंड अ पॉजिटिव क्वांटिटी, सो रियल क्वांटिटी की पावर 0, एंड देन वी गेट अप गेटिंग द रिजल्ट एज 1 and this limit will solve as pi by 2 minus 0, which is pi by 2. So this particular value will come out as pi by 2, and this particular value will come out as 1, and this is how we reach to the conclusion of the formula. So this particular formula comes very handy when the questions are there and the limit is from 0 to pi by 2, and the limit integrand is basically sin x or cos x. So this particular formula comes very useful. Okay, so I actually took about the derivation of this particular part, this first part. Okay, and I hope the second part will be also equally true and easily available to derivable for other candidates. Okay, now if you want to actually know why the derivation is important, so there are some students who are actually preparing for BSc mathematics courses. They have this this particular derivations in mind. For JEE students who are actually preparing for the JEE exams, keeping in mind the competitiveness, you don't have to look for the derivation. You just memorize these particular things. These are not in JEE syllabus, but you have to keep these tips and tricks, formulas remembered in hand, so that you can actually and quickly get to the hand-on results. Okay, so I hope this particular formula will be easily approachable by the students during the exam. And if you are talking about some other BSc students who actually want to know about the derivation of this particular topic, then I cannot this particular Walli's formula can also be derived with the help of the beta function and the gamma function. That is the Euler's integral of first kind and Euler's is of second kind. So how will we get to the derivation of this particular result? Now I can touch upon this particular point. Now if there is someone who actually wants to know why this particular thing happens and how this derivation is actually done with the help of beta or gamma function, so I'm going to be talking about firstly. So if there is a beta function, for example, there is a beta function of x and y, so this beta function can be actually written from integrand 0 to 1, and if there is an integrand that is t k power x minus 1 and 1 minus t k power y minus 1 dt, then this value actually known as beta function, and this beta function solution comes from this particular thing, that is gamma function. Okay, so that is gamma of x into gamma of y divided by gamma of x plus y. So this particular solution comes from here. Now what we can see over here, and we know the sine and cos are related by sine square x plus cos square x is equal to 1. So what we see over here, if we try to put t as sine square u, and then what will be 1 minus t, and this will be basically cos square u. And if we try to dt, if we take dt, what will dt? That dt will come out as 2 sine u cos u. Okay, now whenever we approach this particular result, and if for example there is a term of a and b, and if I go and approaching, and for example if t is equal to 1, then u ka value kitna hone wala, that is pi by 2, and if t is equal to 0, then u ka value 0. So this is the limit that comes and same as the Walli's formula, and there will be a 2 over here, and simultaneously you will get the result as a sine ki power 2a minus 1 u into cos ki power 2b minus 1 u into du. Now these particular things comes again same to as the Walli's formula. If you take this 2 of this particular side, and whatever we are left with this particular reconciliation, for example the reconciliation Wn is represented, and this can be written as gamma of, for example if I take a का वैल्यू n plus 1 by 2 में लेता हूँ और b का जो वैल्यू है that is half लेता हूँ, then what we get this result is beta of n plus 1 by 2 comma half, and this will be half times of this, and then we get the reconciliation that is actually that जो मैंने derive किया, that is 0 to pi by 2 sin की power nx dx. So you can see if you put a की जगह n plus 1 by 2, then you will get sin की power nx, and if you put half over b के जगह तो cos के जगह 0 आ जाने वाला है. So in this way you can approach this Walli's formula. I will talk about now what you can see, if Wn is half times of beta function of n plus 1 by 2 comma half. Now this particular thing can be also be written as gamma function of n plus 1 by 2 into half gamma of half divided by gamma of n plus this will be n by 2 plus 1. Okay, now if I solve, you also know this particular result, if u is a positive number and gamma of u plus 1, then this can be written as gamma of u into, that is gamma of u into u, and this particular result can also be written as factorial u. Okay, so if we from here, if I go on and approaching, if I put n is odd, so if n is odd, then I can write n as something as 2p plus 1, where p is some integral quantity, so I can represent this odd number as something like this 2p times of plus 1, and if I represent this 2p times of plus of 1, so for odd number, for odd quantity, then I will get this result as gamma of p plus 1 into gamma of half divided by gamma of p plus 1 plus half by 2. Okay, and you know gamma of half is basically root pi. Now this particular results I will be talking about when I will talk about the topic of engineering mathematics. Okay, now if you are interested about this particular derivations, you can also watch my lectures of engineering mathematics, which I gonna be soon putting up on the channel. Okay, now if you solve this, and this will come out as p factorial into 2 ki power 2p divided by 2p plus 1 factorial. Now I have solved this particular thing, and if you expand again this particular relation, then you will get back to the particular relation that I talked about in the form of a product. And simultaneously, if n is even, then I can write n something as 2p, and this particular for even quantity this will come out as gamma of p plus 1 into gamma of half, and this particular relation if I solve it, and you will get with gamma of p plus 1, and this particular I have solved it, and this comes out as 2p factorial divided by 2 की power 2p into p factorial whole square, and last में pi by 2, and this is how the pi by 2 factor is established whenever there is an even number, and if there is an odd number there is nothing called pi by 2 but there is a factor of 1. Okay, so I hope this derivation was very wonderfully clear, and अगर JEE का student हो तो only have to memorize this particular relation, and this comes very handy. So I will take a small example to illustrate my words. Okay, I will take a small example. So I hope you have written down this particular derivation, and if I clear it up and I take one important question to show up how you can actually get to the result very quickly, and these results are very exclusive and only applied for competitive exams. Okay, you don't and go on and apply in the CBSE board exam में, ठीक है, क्योंकि you have to show the derivation actually, and this particular thing is not included in JEE syllabus, not in the CBSE syllabus as well, ठीक है. तो I will make it very clear. So for example, if I take a question of integral is given and the limits of the integral is 0 to pi by 2, make sure करना कि 0 to pi by 2 होना चाहिए. अगर 0 to pi by 2 नहीं होगा तो वालिस फॉर्मूला मत अप्लाई करना, ठीक है ना. तो अगर क्वेश्चन में दे रखा है फॉर एग्जाम्पल देर इज साइन की पावर 4x इंटू कॉस की पावर 6x dx, सो इफ यू ट्राई टू सॉल्व दिस पर्टिकुलर क्वेश्चन इट विल टेक अ मच टाइम इन योर ओन वे, और इफ यू अप्लाई द फॉर्मूला लाइक कॉस स्क्वायर को थोड़ा सेपरेट करके लिख लेते हैं, और इफ यू ट्राई टू अप्लाई द सब्स्टिट्यूशन मेथड देन इट विल टेक अप टाइम. सो आई कैन डायरेक्टली राइट दिस रिजल्ट, क्योंकि लिमिट्स का जो वैल्यू है ना वो अपना फेवरेट लिमिट्स आ गया जैसे 0 to pi by 2, एंड वी कैन डायरेक्टली अप्लाई द वालिस फॉर्मूला, एंड व्हाट आई विल राइट ओवर हियर नाउ. अब देखना जब साइन और कॉस दोनों साथ में है ना तो वालिस फॉर्मूला थोड़ा डिफरेंस है. व्हाट इज द कैच ओवर हियर? आई विल से द कैच इज फर्स्टली m-1 और उसको लिखो, एंड नीचे जो लिखना है ना जो डिनोमिनेटर है ना वो डिनोमिनेटर में m+1 और उसके बाद m+n देन m+n-2 ऐसे करके लिखना है. सो दिस इज वेरी इंपॉर्टेंट, ठीक है. तो सेकंड वाला फॉर्मूला में जब कॉस और दोनों साथ में आता है ना तो दिस पर्टिकुलर फॉर्मूला इज अगेन इंपॉर्टेंट, और ये तो इंपॉर्टेंट है ही जल्दी जल्दी क्वेश्चन सॉल्व करने के लिए. ओके, सो मिस्टेक्स वही होता है जो नीचे वाला डिनोमिनेटर में सोचते कि जो ट्रेडिशनल मेथड में करते जैसे 4 - 3 इंटू ऐसे करते थे तो उस मेथड से करने लग जाते हैं, बट दैट इज रॉन्ग. जब साइन और कॉस दोनों साथ में है देन वी हैव टू अप्लाई द सेकंड फॉर्मूला. सो इफ आई अप्लाई द सेकंड फॉर्मूला दैट इज 3 into 1 डिवाइडेड बाय इंटू, and for this is for the particular sign, numerator of the sign, and if I multiply 5 into 3 into 1, and if I multiply the denominator, what I will get? I will get that I have to firstly multiply the sum of this particular number, that is 10 into 8 into 6 into 4 into 2. Okay, and I will end up, and what I see over here कि दोनों जो नंबर है ना दोनों ही इक्वली इवन है. अगर कोई एक इवन होता कोई एक और होता देन वी कैन नॉट मल्टीप्लाई बाय पाई बाय 2, बट दोनों ही साथ साथ इवन है देन यू हैव टू मल्टीप्लाई बाय द नंबर पाई बाय 2. Okay, and I hope this was clear how I actually take these particular things. दो का डिफरेंस से घटाया ना जा रहा है, ठीक है, 2 का डिफरेंस से घटा रहे हैं. ओके, सो एक्चुअली 1 का डिफरेंस से घटा के एंड लिख रहे हैं. तो बेसिकली देयर इज अ लाइक माइंड में होता है ना कि 2 डिफरेंस से लिख रहे हैं, तो 10 लिख रहे हैं, उसके बाद 8 लिख रहे हैं, देन 6 लिख रहे हैं, 4 लिख रहे हैं. सो इफ आई एक्चुअली सॉल्व दिस, दिस विल कम एज दिस विल 15 into 3 दैट इज एक्चुअली 45 पाई. एंड इफ आई सॉल्व दिस, ओके लेट अस टेक सम सॉल्व थोड़ा कर लेते हैं. अगर सो 3 से इसे काटे तो 2, and what I see this is 15 pi by, this will be 15 pi by, this will be 15 pi by, and if I compute this product, okay, this will be 16 into 8 16 into 160 into 8, that is 512. okay, and 512 आने वाला क्योंकि अगर मैं इसको 2 से डिवाइड करा तो 2 की पावर 3 2 की पावर 5 and 2 की power 8, so that is 512. so the answer will be directly as 15 pi by 512. okay, so directly आप देख सकते हो रिजल्ट को अप्रोच कर सकते हो. so in this way you can solve the competitive exam question in very quick approach. okay, so you have to remember the Walli formula in very